Thank you all for joining us today. My name is Michaela Freeman. I'm from the Pacific Northwest National Laboratory, or PNNL. I'm a research scientist and project manager here, and just want to start by welcoming everyone to our Marine Energy Career Panel. We'll feature staff from 3 of our U.S. Department of Energy national labs, so we're really excited for today. Just a few quick notes. One, we are recording this event. We'd like to make these career panels available online later, so you'll see them on TTHIS after the event, and we'll send out an email that everyone who registered will get. And then the other thing, if you would like to ask some questions today of our panelists, you can go to the Q&A box down at the bottom of your screen. I think that's where it should be for most people. And you can put your questions in that Q&A box, and we will try to answer some of them through our discussion, but we may also be able to answer them just through the Q&A box itself. So that's a great place to put any questions that you have, and we'll try to get to as many as we can. So diving in, before we get started, I just want to give a brief overview of the national labs. So the U.S. Department of Energy, or DOE, has 17 national laboratories. Their aim is to strengthen the U.S.'s global leadership in science and innovation and tackle some of the country's most critical scientific challenges. We do that by driving new energy technologies and advancing scientific research through a multidisciplinary approach that really places an emphasis on translating basic science to innovation. You can see the labs on the right here. Each of them have a unique set of capabilities and areas of expertise. And today we're going to be highlighting staff at 3 of our national labs. So PNNL, the National Laboratories of the Rockies, or NLR, formerly known as NREL. So for those of you who knew it as NREL before, they are now NLR, and then Sandia National Laboratories. So these are 3 labs that are really working on marine energy, and I'll talk a little bit about them in the next few slides before we get this panel started. So first is NLR, which is located in Colorado. They focus on energy systems innovation and integration. Regarding their work on marine energy, they conduct research, development, and economic analysis on marine energy technologies. They do things like modeling, device performance simulation, laboratory testing, open water validation, and more. You can see a lot more of their capabilities listed here. The next lab is PNNL, which is based in Washington State, but we also have offices in Oregon and DC. We have a variety of key research areas for the lab as a whole, but for today, again, we'll focus on our marine energy work, where we aim to understand marine energy opportunities and overcome technology, environmental, and operational challenges. We do this through modeling and resource characterization, environmental effects research, supporting industry, and more. I do want to note that we have our SQUIM campus shown here on the bottom right, and it's DOE's only marine research facility, making it uniquely positioned to advance marine energy through its bench to bay testing capabilities. And among the various marine energy work undertaken at PNNL are efforts on environmental effects of marine energy, which we tackle through 2 of our initiatives, OES Environmental, which is led and implemented by PNNL. It's an international initiative, and the Triton Initiative, which you'll hear about from our staff as well today. And then last but certainly not least is Sandia, which is located in New Mexico. They provide expertise in engineering, security, and renewable energy innovation. And for marine energy, they lead efforts in device design, testing, and modeling, particularly through their Wave Energy Converter Simulator, or WECSIM. And they also do research on materials, controls, and performance optimization. So I know that was a lot of information, but just wanted to give you a really brief overview. But really what we're here today for is for our panel. So with that, I am going to pass it over to Simon, who will get our panel kicked off.
Great. Thanks, Michaela. And thank you to all the organizers, all the panelists, and all of you here today who are joining us to learn more about what it's like to work for a national laboratory on marine energy issues. Of course, I just lost my notes as soon as I started talking, so let me just shift the screen over here. Okay. Sorry about that. So I'm Simon Gerlofs. I'm a senior advisor here at PNNL. I work with a lot of our different national lab partners on marine energy issues, as well as other ocean technology challenges and opportunities. And I've been at PNNL for about 17 years. And I guess I've sort of started out as a junior scientist, worked my way up the chain through project management, served for our partners at DOE, and now I'm as a senior advisor, I get to work more on some of these strategic issues and kind of thinking about sort of the future of the marine energy industry and where we're going to go. So it's been a really cool career path for me, and it's really exciting to have a chance to interact with many of you who are interested in learning more about this career path and with our panelists. So we have a really great panel. Our panelists were selected to show a real broad range of sort of different expertise, different disciplines, and to highlight the different career paths that are really available within the marine energy sector. So what we're going to do is we're going to let each of those panelists introduce themselves. So we have one slide each. They'll take a couple minutes to tell a little bit more about who they are and where they came from. And after that, I have a set of prepared questions that I'll engage the panelists with. But as I'm asking those questions and as you're hearing the panelists introduce themselves, please do use that Q&A function to put questions of your own up there, and we're going to kind of weed through those questions and ask them as we go. So, a few prepared questions from you, and then when it's all said and done, Michaela's going to come back and she's going to close out the panel and provide some additional, very specific information about opportunities, fellowships, and other ways of getting involved with national labs and DOE research. So some of your questions might also be answered there. With that, I think I'm going to turn it back to our panelists. And Michaela, you have the slides there. Our first panelist is Linnea. So Linnea, why don't you take a couple minutes to introduce yourself and we'll go from there.
Thanks so much, Simon. Hi, everyone. I'm Linnea White. I am a mechanical engineer with PNNL. My background was in mechanical engineering. I did a Bachelor's of Science at Seattle Pacific University in mechanical engineering and general engineering. And then immediately after graduating, I ended up finding a job posting for a post-bachelor's research associate at PNNL, and ended up networking my way to my first manager. So I started working out at the SQUIM campus, supporting various mechanical design for sensors that were going into SQUIM Bay for different projects, monitoring the environment there, also working with marine energy devices, helping devices and developers test in our tanks in SQUIM, where we do some biofouling work, and also putting devices out in the bay. Yeah, and I eventually transitioned to a full-time staff as opposed to the research associate, and have continued working with PNNL ever since. In my free time, I like to bake, climb, go line dancing, lots of really active, fun hobbies. Thanks.
Did you actually bake those croissants? They look really good. Kind of
No,
making me hungry.
Michaela asked me that too. That is a stock picture, but I have baked croissants and they do turn out looking rather lovely.
Nice. Lamination. It's all about the lamination. Thanks, Linnea. Sarah, you're up next.
Hi, everybody. My name is Sarah Wallen. I am a research technician with the National Lab of the Rockies, formerly NREL. I've been here for about 12 years now. And my career was a little bit different, I would say. I actually started out as a business support staff as kind of a way to, get my foot in the door here at this place that was, a dream to me. And I ended up transitioning over to the research technician staff a few months after starting. And so ever since then, I've been kind of just working on many different projects. When I first started, I worked a lot out in the fields. So climbing wind turbines and installing instrumentation on our Met towers and up in the nacelles and hubs and blades of the turbines that we have on site. And I've kind of transitioned over the years to more components testing and then blade testing as well. So we've done quite a few water power blades and then a lot of different components testing with water power and, just doing some really cool things with soaking coupons in different seawaters and all that kind of stuff. But I got my degree in environmental studies from the University of Colorado Boulder, and kind of had a few little jobs after graduating, but then started here with NLR, and I just love it. And yeah, it's a transitional time right now, but I'm excited to see what the future holds. And then I enjoy in my free time definitely hiking with my family, exploring different ruins and stuff in Utah, and rafting and mountain biking and doing all the things. So yeah, I'm excited to see what we have to say today. Thank you.
Sarah, that job sounds amazing. I want to climb turbine nacelles and hang out and on my spare time go rafting in Colorado and Utah. So sounds really cool. Thank you. Next up is Jeff.
Everyone. Thank you, Simon and Michaela. My name is Jeff Grassberger. I'm an R&D mechanical engineer at Sandia National Laboratories. So I got both my bachelor's and my master's in mechanical engineering from Virginia Tech. During my master's, I joined Sandia as an intern. Sandia intern program kind of allows for both summer and year-round interns. So I was able to kind of align it with my research during my master's to some extent and work a little bit during the school year. And after getting my master's, I joined Sandia as an R&D mechanical engineer. So throughout my internship, I focused primarily on Wexim, kind of getting a good background in wave energy converter modeling. And then after that, was able to branch out into what we call control co-design of wave energy converters. So kind of considering a holistic picture of the wave energy converter, the power takeoff system, and the controls, and trying to develop, come up with optimal wave energy conversion through that process. And then I also focus on some other kind of application projects where we look at applying wave energy for desalination and aquaculture or other applications. And a little bit more about myself personally. I love to play board games, ultimate frisbee, and then just love to get outside into nature, doing hiking, backpacking, trail running.
Great. Really nice to meet you, Jeff. Thanks for that. And up next is Kayleen.
Hey everybody, my name is Keeleen Gunn. I'm an earth scientist and science communicator in PNNL's Coastal Sciences Division. I've been at the lab for about 9.5 years now, and I graduated with my bachelor's of science in geology from Bates College in 2016. And after playing around outside as a guide over the summer, my first career job out of college was at PNNL. I have always had the intention of going to grad school, but my career has often offered so many cool learning and work opportunities. I am still here working off my bachelor's of science. In my undergrad, I did a year-long thesis that was related to research a PI in our division was standing up. So that's what connected me to the lab, and I landed a post-bachelor's research associate position similar to Linnea. My first couple of years at PNNL in this role were dedicated to wetland ecology research. I did a lot of field work and lab work and playing in the mud and on boats, but I also got exposure to a number of other projects, which is one of the cool things about that role. And one of those projects was the Triton Initiative, which Michaela mentioned. Triton focuses on environmental monitoring for marine energy and works to address environmental effects knowledge gaps. And this is the project that brought me into the marine energy space, and I still work on today. I converted to a scientist position in 2018, and since then I've been working on a number of different projects, many of which were related to marine and other offshore energy systems. Also, early on in my career here, I was trained as a STEM ambassador, which really launched me into this world of science communication and really opened a whole science communication and STEM education focus in my work. Now I support interdisciplinary research related to marine energy environmental effects, as well as social ecological systems research around energy development. More recently, I'm conducting science communication research to help improve the translation of science to different end users. I do that in the marine energy space. And then I also do a lot of technical science communication and STEM outreach. My career has been winding and has shifted a lot over the years. And I work on a number of projects at any given time, but my current work has really landed at the intersection of all my interests, which is something I'm really grateful for. Outside of work, I love making art and playing outside on bikes and skis and in the garden. Anything that gets me out in nature keeps me happy.
Kayleen, I love your career path map. That's kind of inspiring. We should all write one of those down. See all the twists and turns. It's really cool.
Yeah, it's very fun to make.
Excellent. Okay, I think Hannah, I think you're last but not least, I'm pretty sure. So take it away, Hannah.
Yeah, thanks, Simon. So hi everyone. My name is Hannah Ross. I'm a research engineer here at NLR. I've been at the lab for about 5.5 years. Um, I did my bachelor's in mechanical engineering. And during that time, I did some work kind of through internships and co-op assignments in manufacturing and industrial energy efficiency. I also did a research internship as well during my bachelor's. That was kind of my first experience working in the research space. I knew I was interested in kind of this field in energy and fluids and renewable energy. And so during my or after my transition from my bachelor's, I went to I went to the University of Washington for my master's and then stayed on as a PhD student, still in mechanical engineering. And so kind of went straight through. And then after completing my PhD, I came to NLR as a postdoc and completed 2 years of a postdoc and then transitioned to a kind of full staff researcher role. My work in grad school is kind of shown in the first set of pictures here. I did a lot of laboratory scale testing of marine turbines with a specific focus on cross-flow turbines and kind of looking at scaling and flow confinement effects for turbine performance and operation. Since coming to the lab, I've shifted my focus kind of more to the numerical modeling side. So really the pictures in the middle here should be more focused on numerical modeling, but it's hard to get exciting images of numerical modeling. You just have a bunch of code or maybe a visualization of the system you're analyzing if you're lucky. So I put a couple of pictures of some of the other projects I do at the lab here that are a little more photogenic. So the top one is some tank testing work that we've done to kind of analyze a hybrid mooring system. And then a field deployment that I was involved in at the University of New Hampshire is shown down below there. Outside of work, I think kind of following a common theme of a lot of folks that you've heard from so far, I like to get outside skiing, camping, hiking, etc. I also sing in a social choir in Denver, which is kind of a nice way to just do something very different from my day to day.
Great. So did you sing in college or high school before, or just start singing socially after you got to Denver?
Yeah, I did mostly a tiny little bit in high school, but I sung in college in like a non-auditioned choir in my undergrad. I got to grad school and I was like, I don't think it's feasible to be in a choir and do grad school at the same time. But then when I finished grad school and moved to Colorado and found this choir in Denver and started back up, which was really nice.
That's excellent. I like the common theme. All of you do have such interesting activities and interests outside of your work. So there's the possibility of work-life balance in your careers. At least you're telling us that, so that's great. Okay, I think what we'll do now is shift to the discussion, and I'll just remind folks who are listening, if you have questions, I'll start with the set, but if you have questions, use that Q&A function, and we'll kind of go back and forth between your questions and my questions. And the first set of questions we're going to go really around all the panelists, and they're really around how did you get involved in this kind of work, and what does your job look like, and then kind of what surprises you about your work. So we'll start with how you got involved in this interesting field of marine energy. And, I feel like when I talk to folks, oftentimes there's sort of two pathways. One might be like you were a marine and coastal scientist that kind of got interested in this interesting technology in the ocean. The other path might be you're a technologist or someone focusing on energy or engineering that kind of stumbled into the ocean through that pathway. But I'm curious from your perspective, how did you initially get involved with this subject matter? And what would you suggest those listening might do to get involved if they are also interested? So maybe I'll start. I'm just going to go down the top of my list, and I see Kayleen at the top. So Kayleen, do you have any thoughts on that one?
Yeah, so like I mentioned, my background is not in the marine energy space at all. But as a research associate, one of the cool things about that position is you often get to support different projects in different ways. And for Triton, I was given a task to help develop a website for lay audiences, and I loved it because I got to learn about all the cool research going on in the environmental effects space, and I got to work on that like translation of science from technical to lay audiences, and that really lit a fire under me. So that kind of propelled me not only into the environmental effects research space and into the marine energy world, but also technical science communication, which was very cool and a big part of my job. And I would say that one of the things that I've learned along the way is that if you're interested in some of these like less technical things like science communication, art, there are ways to apply research questions to those and really sort of build your research around those interests. And I've been able to do that in marine energy, which is really cool. And I would say my biggest piece of advice is if you are passionate about something and you see a little opportunity, say yes to it. And you never know, you might be working on that project for the next 8 years, which is what happened there. And totally introduced me to marine energy. And that's something that has been a real gift.
I like that aha moment that your creative side also is important in working in this field. It really takes different ways of looking at a problem. So that's really cool. Thanks, Kayleen. And has it really been 8 years? That's crazy. Time flies. Up next, how about Jeff? How did you get involved in this field? And what are your suggestions for those who might be interested in similarly being involved?
So, I guess kind of going back to college, throughout my engineering studies, it was kind of a goal of mine to get involved with renewable energy in general. Of course, my first thoughts at that time were more like solar wind, but there weren't any professors at Virginia Tech that kind of focused on either of those. But instead, there was a professor that focused on marine energy. So that was kind of my first introduction, was just kind of looking at the professors and seeing what research I could join. And I actually, it was an email chain about the marine energy collegiate competition. And it was during my senior year of college, so it was a busy time, but I kind of said yes and just figured, it's something that I could see being important to the rest of my career. So it was something I really wanted to yeah, prioritize. And that's kind of how I got introduced to the research lab I got involved in for my master's, and then eventually um, onto Sandia and was able to continue my intern or start my internship and continue with marine energy here. Um, so I don't know if there was necessarily an aha moment for me, but just being kind of like Kayleen said, just being willing to say yes, even when uh, it's a busy time, saying yes to the opportunity that feels right. for me was really important. And just being willing to kind of reach out to professors or just others in the field and talk to them. And most of us in the field, I think, are very happy to talk about marine energy and the potential and uh, more about the stuff that we're passionate about.
Yeah, thanks, Jeff. I think that the power of yes is a really important theme. And then as you get a little bit further along in your career, then the power of no comes in. How do you start to sort of down select? But I think yeah, I really resonate with that too. The yes, I'll do that. I'll take notes. I'll do this thing, whatever that is kind of how you get your foot in the door. So I resonate with both those answers. And for the panelists, we're going to go Sarah, Linnea, Hannah, just so you guys can kind of get your head around when you're coming up next. I hate it when you don't know when you're coming up next. Then we'll reverse the order for the next question. So Sarah, you're up next with this one about how you initially got involved and what advice you'd give.
Yeah, so I would say as a research technician, I am involved in quite a variety of different projects here on site. So I work at the Flatirons campus, um, which, I guess traditionally, we have the wind turbines, we have dynamometer facilities, we have the facility with the wave tank. So, for me, it's kind of like I was involved in these other projects, and as water power became more prevalent here on site, I was kind of pulled into helping with those projects as well. Um, I would say for me, like my aha moment was actually when I was taking a tour of our site before I got a job here. I got to go up one of the smaller wind turbines, and that for me, just being up there was like, wow, this is cool. How can I get a job here? How can I get involved with this? Um, and kind of like other panelists have said, just really being open and taking opportunities. For me, I had no electronics or, mechanical background. My degree in environmental studies was very much a study of, different aspects of the environment. So to become a research technician, was every day something new, learning something, taking safety trainings on, how to safely work with electricity and, just being open to all of that information, I think was really important. And I would just say that, don't box yourself in. Um, you can really do anything you put your mind to. And yeah, if you see something that looks fun, just have the courage to go for it and, go find that manager or go find that project leader and just put yourself out there. So yeah.
Putting yourself out there and having that courage is oftentimes one of the harder things, but if you can practice that, it really is the door opener. And I think most folks I talk with, maybe you might have six different careers at a national lab, just kind of following your interests and what the mission is, what's required of the mission as the mission changes over time. So really appreciate that. Thanks, Sarah. Linnea is next, and I'm seeing some good questions coming in on the Q&A too. So thanks for those of you asking questions there. But Linnea, how about telling us how you got involved and what advice you'd give?
Yeah, I definitely was drawn to my job through the technology pathway. Um, there were two different projects that I was involved in college that sort of drew me to energy. I did a summer research opportunity with one of my favorite professors where I ended up helping size a solar power system, which I thought was really fun. Um, and then on a study abroad to Ireland, I took a class that was all about wind energy, and the class was project based. So I ended up working with a team to like scope out a potential site for a wind farm and then work on site characteristics and capacity factors. And I also really enjoyed that project. So when I started job hunting after college, I was looking for renewable energy projects. I actually didn't know marine energy existed until I found the job posting that I would eventually be hired for. So I didn't even realize I was looking for this until I found it. Um, and once I did find it, it was really all about the networking that I think ended up getting me the job. I had seen someone really interesting post on LinkedIn about a job at the National Lab and had just applied to the posting there. So I reached out to her and asked her to do an informational interview with me. Um, and she worked in a slightly different area, but was able to connect me with the guy who would end up being my hiring manager. So my advice would be basically if you see someone doing something interesting, reach out and ask if you can have a conversation. Odds are they'll be really happy to talk to you about it, or at the very least, send you a little email about it. I would say never say no to yourself. Let someone else say no to you.
Write that down. Never say no to yourself. Let someone else say no to you. And hopefully they don't say no. Hopefully they say yes. Thanks, Linnea. Hannah, why don't you take us home on this question about how you got involved and what advice you'd give?
Yeah, I would say kind of similar to Jeff, I knew that I was interested in working in the renewable energy field when I was in college. I had chosen mechanical engineering specifically because I'd been told that it was kind of more broad, or you were able to kind of go more different directions. Whether that's true or not, it was a professor in mechanical engineering who told me that. So, but anyway, that's where I ended up. And I was really drawn to kind of like the fluid dynamics side. And so going into graduate school, I was initially looking at opportunities in wind energy, but just kind of through searching for different research labs and groups related to that topic area and that research area, I came across the research lab at the University of Washington, where I ended up doing my master's and PhD. And at the time, I had never heard of marine energy before. I kind of, learned about it just from looking through kind of the work that they do and the information that was available online. And I could see that, in some ways it looked like, at least for like tidal energy, there were some similarities to wind, but maybe, it was a newer kind of less established field. And so it seemed like maybe there were more opportunities for novel research or ideas. And so it seemed just kind of a bit more exciting, a little bit newer. And that's really how I kind of ended up in this field. And so the lab that I joined for graduate school is really focused on marine energy. And so that's what my graduate work was in, and then where I've stayed into my career. I think it's a really unique community, just the marine energy community in general. And I would say, I think there's a lot kind of more opportunities available, especially now for students to be engaged in marine energy and learn about marine energy, kind of in advance of having to make the decision of where really you want your career to focus on. And so I think taking advantage of some of those opportunities, internships at national labs, marine energy collegiate competition, that sort of thing, are really good ways to get connected and to get into the field if that's of interest to you.
Anna, yeah, I'm often struck by how new this field really is. I mean, it's really only been something that there's been DOE started the water power program, I think in 2008, 9. So really a relatively new space for engineers and folks working on energy or working on coastal issues. And so it does kind of give you that exciting opportunity to kind of forge a new pathway, which is pretty cool. I'm seeing a couple questions in the Q&A that are for individuals. So Jeff, I saw you just answered one by typing, which is great. And I think there was one for Linnea as well that I saw, but maybe Linnea, you got it because it just disappeared. But so that's great. If you have a specific question for a specific panelist, go ahead and just tag their name, and we're keeping an eye on that. We can just kind of take it offline. So we're going to keep going with our questions, and then we'll turn to your questions. And the next one is sort of going more specifically about what your day-to-day looks like in your job. Kind of thinking about what are you actually doing with your time in this field? Kind of give us a little bit of a behind the scenes. And I'll go backwards this time. I'll go Hannah, Linnea, Sarah, Jeff, Kayleen. So you guys kind of know where you are in order. And Hannah, go ahead.
Yeah, I would say um, kind of these days, my day-to-day, my job is probably split fairly evenly between kind of project management and PI roles and that sort of work. And then actual research, coding and numerical modeling. Um, so as I've kind of gotten a little bit further along in my career, it's been, I would say, um, something that I've honestly maybe enjoyed more than I thought I would, as far as like stepping into more of a project management, project leadership role. So within that role, I get to kind of think about research directions that I think it would be valuable for the research group or myself at the lab to take. And so that involves, writing proposals, looking for funding opportunities, and kind of brainstorming around what types of topics I think, we should pursue or look for opportunities in. Um, there's definitely some more kind of logistics work around project leadership too, just planning out staff time and hours and making sure budgets are on track, that sort of thing. And then I would say the other half of my work related to actually kind of executing on the technical work. Sometimes it looks like just trying to add a new feature in a piece of code so that we can model something that we want to do, tracking down a bug or troubleshooting something in the software that isn't working, or kind of applying those modeling tools to support industry partners or specific research questions. So, modeling someone's new turbine in our tools to try and tell them how their performance works. So in that regard, kind of engaging with external partners and clients as far as kind of guiding project direction and looking together at outputs and kind of compiling, what comes out of a project. Yeah, I would say that's kind of an overview of generally what I do. There's lots of meetings and answering emails kind of sprinkled throughout there as well.
So that for sure. I might just do a little combination of this question and the last question, just because it might make sense to kind of stick with each of you on this. But given what you just said, is there anything that really surprises you or that surprised you about? So when you were in graduate school, did you think that you would be spending that much time working on budgets, for example, when you were studying fluid dynamics? Like, is there anything that like really jumps out at you as just like not what you were expecting? And if so, would you have wanted to do something else as an undergraduate or a graduate student to prepare yourself for that?
Yeah, I actually thought of this answer when some of the other panelists were kind of giving their introductions. And I would say one of the biggest things that surprised me, especially from undergrad on to graduate school and then my career, is how much of my job centers around just talking to people as an engineer. Especially in undergrad, that's not what I was told, or at least that wasn't the impression that I got. It was like, you're going to be an engineer, you'll sit by yourself in a corner and solve problems or make drawings. I don't know. And definitely the opposite of that is true, at least for me. It's been incredibly critical in advancing my career to be able to collaborate with people, to take those steps of putting myself out there, going to talk to people at conferences, initiating collaborations, or uh, you know, just asking questions of someone, establishing mentorships, that sort of thing. And so I wouldn't say I would do anything different or choose a different path. But I think that's one of the things that probably surprised me the most from my undergraduate time to now, and that maybe took kind of a lot of practice or a lot of pushing myself to kind of become better at and kind of accept that as something that was necessary.
Great. Thanks, Hannah. That was awesome. Linnea, how about you? So, what does your day-to-day look like? And then also thinking about what about your day-to-day is different than you might have expected when you were a student.
Yeah, so I think one of the wonderful things about the National Laboratories is the range of different projects and tasks that you can end up working on. I have like some projects where I'm doing mechanical design, I'm building a lander, or I'm mounting sensors to someone else's lander. But I also have projects where I'm doing modeling work and I'm writing up Python code to model a tidal turbine and the loads it experiences and the power it generates. Um, or I can be planning a deployment in SQUIM and writing some paperwork that's required to put our devices out in the water. Um, so I think my day-to-day looks very different depending on the time of year. There'll be a lot more fieldwork related things in the summer and a lot more computer-based work in the winter. And also just depending on which projects are active at the moment. But generally, I'm trying to block out time around meetings to get some deep thinking work in. Really grateful for PNNL's No Meeting Fridays. That's fantastic. Highly recommend. Um, yeah, so I think it's really interesting. It's always changing. I think one of the best skills you can actually have going into research is your ability to keep learning and picking up new skills and new information. And I think that that range of different things that I have access to experiencing is what surprised me about the job. Coming in, I was similar to Hannah, also thinking that I would be doing a lot of mechanical design and I would be in my little engineering box. And here we are a few years later, and I'm, writing paperwork for deployments and running projects, and that pathway to taking on more responsibility and moving into project management, that's been really exciting and surprising for me.
I wish there was such a thing as a no meetings Friday, but theoretically there is such a thing. So yes, it is amazing how much time meetings take up. I'm sure it's the same in all of our careers and also as students, just the sort of the ubiquitous nature of these tools like Teams and Zoom means it's easier to meet, so it's harder to kind of carve that space off to go into your engineering box, as you said, Linnea. That is a challenge. Sarah, how about you? What does your day-to-day look like? We already are picturing you in turbine nacelles and whatnot, but I'm sure it's different than that. And then any major surprises?
Yeah, so I would say similar to our other two panelists, it changes really day to day, week to week, depending on projects that are, up and coming or projects that are in the process of happening or, we're decommissioning. So I would say a typical day for me is either helping to set up a new test. So that's getting equipment ready. I'm in charge of our data acquisition systems for a lot of our structural testing and components testing. So, making sure that our computers and instrumentation are all ready to go. We are an accredited laboratory, and I'm in charge of our calibrations for equipment as the deputy technical manager. So I spend a lot of time just organizing our equipment, making sure that what we have for upcoming tests is calibrated, or if a test is running longer than a year to 2 years, like making sure that that equipment gets recalibrated, setting up hydraulic systems. I am kind of our subject matter expert for hydraulics. So, depending on a test that's coming up, I might be setting up the controls for that. But really, it's a lot of kind of just jumping around to different facilities, over like a week to a couple weeks, and then potentially running the tests. Um, yeah, and just kind of being flexible with what's coming up and what's needed for the tests, and working closely with the PIs and other technicians to make sure that, things are running smoothly. We're getting the equipment that we need, either purchased or calibrated, or, you know, whatever's needed for that. So yeah, flexible.
Well, and it sounds like a lot of diversity in the day-to-day, which probably keeps it
Yes.
very interesting.
Yes, it does. Yeah, lots of different groups and lots of different test equipment that we have here on site. So it's pretty exciting, I would say. So
Cool. Thanks, Sarah.
yeah.
Uh, all right, so we got Jeff and then Kayleen. Jeff, tell us a little bit more about your day-to-day and what you are surprised by.
Yeah, so in my day-to-day, I definitely do a lot of coding in the form of software development, software maintenance for softwares like Wexim um, and other related ones. So um, in terms of kind of research projects, a lot of that is utilizing those software projects in order to build out different wave energy converter models and kind of completing design analysis on those. I think one thing that's cool about marine energy, at least in the numerical modeling space, for me is there's a lot of different um, kind of subjects that go into that. So we work with the fluids side of things, we work with the dynamics, the controls. So a lot of engineering background can be really useful. Um, and it covers a wide variety there. We also kind of my team works a lot with the Teamer program, where we get to support wave energy developers with kind of some newer concepts. So get that opportunity to explore new wave energy concepts and also just providing support to the marine energy industry in that way is fulfilling to me. I think what maybe not surprise fully, but something that I think a lot of people talk about, but maybe at least during school for me, I didn't focus on as much was kind of the communication and soft skills that are really important to certainly any career, but especially I think in research, just being able to network and collaborate with people both on your direct teams at your lab, but also outside of that at different labs and um, different universities really helps to expand the potential of what the work you can do when you can kind of work well with teams and work well with other people who have expertise outside of your direct field is really valuable for getting involved in future projects.
Yeah, and I think that as I'm more of a policy like person, and for me, it's kind of the same. Like how could we learn more about the engineering side of things? How do we? It's always that crosswalk between, your expertise and your discipline, but then having that breadth to be able to kind of fill in both sides of it. So I think it works both ways. I think it's might be harder to learn the engineering side though. So I don't know. It's all challenging, but it's all good. Kayleen, you haven't talked for a while, so how about tell us about your day to day and what has surprised you about it?
Yeah. So like the other panelists here, no day of mine really looks the same. I wear a lot of different hats and I love it that way. It's something that I adore about working at the National Lab. I work on probably 10, 15 projects at a time. So I really work on multiple projects a day, almost every day, unless I can carve out some deep working time when we don't have a lot of meetings, which is always a challenge. But sometimes my day looks like talking to our different technical leads about their specific marine energy research and helping them translate that to different audiences, even technical audiences. So sometimes that's like translating to a regulator or a developer that speaks a similar technical language, but it's not quite the same, and just helping making sure we're translating that research. Sometimes I'm making science art. Sometimes I'm conducting lit reviews and developing conceptual models that represent complex systems of energy development, communities, and ecosystems. And that's really fun, trying to visualize how these complex systems work and understand what the challenges are and how we can maybe solve some of those challenges. A lot of the time I'm working with other scientists throughout the lab, helping them communicate their work. And then sometimes I'm interviewing different end users, understanding how they conceptualize their research and understanding of science and what that means for their decision making, so we can better develop our research and produce data that helps them answer their questions. So that's something I've gotten really interested in the marine energy industry. We're developing or we're creating environmental monitoring data sets, and we want to make sure that those data sets are answering questions that regulators need to do their jobs, and how can we do that better. So my work looks very different every day, and it's a wonderful part of my job. Something that has been surprising that maybe aligns with some of what the others have said, getting into that soft skills piece. There's a lot more proposal writing and justifying your research and why your work matters than I realized. And sometimes that's not my favorite part of our work. And sometimes it's really exciting because you come up with ideas and you have a chance to pitch those ideas and see who's interested. But the better that you can communicate why your work matters, why you're equipped to do that research, why you have the teams that will make it successful, the better. So that's something that I learned very early on. Science writing is going to take you far, and really communicating that like top line message of like why the work you do matters and matters for whom. So I'd say that's definitely more a part of my job than I ever thought it would be.
The why, I think that is, we always have to keep that in our mind as far as why we're doing the work we're doing. Why are we spending 40 to 60 hours a week doing this stuff? I think we need to know that to keep our own internal motivation going, but also that's how you continue to kind of move the envelope forward and find the next, source of resources to carry your science forward. So thanks, Kayleen. I think we're going to turn to Q&A, and you guys are being so diligent on the panel answering all the questions that are coming in. So, but I did see a couple that I might turn back to and get a little bit of discussion on. And actually, the one that's open right now, I see Hannah, you're typing an answer to Leanna's question, and she asks about, from a reliability perspective, how does marine energy compare to other renewable energy sources like wind, solar, hydro, nuclear? As well as non-renewable sources. So I think we can kind of talk about the reliability perspective, but I was going to twist this a little bit too and ask you how you see the marine energy work you're doing as fitting into a broader context around energy technologies, solutions, however you want to call them, and sort of your sense of your ability to kind of work across those spaces. Do you feel like working on marine energy, you're part of a broader energy dialogue? Or do you feel like your work is really kind of just centered on the technical questions of marine energy? And I'm just curious, we don't have to go all the way around, but does anybody want to take a crack at that?
I'd love to take a stab at that.
Go ahead.
Just going to how my work fits into the broader energy dialogue, I think I see that a lot in that I don't only work with marine energy. That is my main focus. But when we're putting together, for example, a buoy that's going to have sensors on it, we're also talking about what solar power we can have on there too. Maybe we have tidal and we have solar, and we're looking at both of those things working together. And you see like a lot of ways that these energy resources can complement each other. For example, wave energy tends to be higher in the winter when you've got more wind, more storms. But solar energy is higher in the summer. So if you pair wave and solar, then you get this really good complementary aspect to each other. Now I've had projects where I work with companies that design floating solar, and then you have this like interplay between it is marine because it's on the water, but also the energy type is solar rather than a marine energy resource. So I think there's a lot of different ways that these energy types go together, and I definitely see marine energy as falling into a broader scope of things. In some sense, marine energy can be more reliable because you can predict the tides. You can know exactly what power you can expect out of a tidal turbine. Um, but also you have mechanical issues that maybe don't come up on land. If you're putting something in the sea, in the ocean, then you have to deal with corrosion, which is something that you don't really have to deal with something further inland. And that can be really complicated.
Couldn't find the mute button. Thanks, Linnea. Did anybody else have any thoughts after Linnea gave that answer, or any other thoughts on this question? Sarah?
Yeah, just when Linnea mentioned the corrosion, it kind of sparked some ideas. And I mean, just it seems like there's a lot of room for research with water and marine energy because you have that component of the sea or, water, rivers, with, the electronics. It seems like there's still a lot of room to like figure out how to make it more, you know, um, like how to make it more reliable and how to make it last longer or, in different types of water sources, that's going to affect things differently. So it seems like to me from like the research technician position that there's still a lot of things that we are understanding and like trying to figure out and even just like getting the power from the device back, to the grid. It just seems like there's still a lot to figure out there versus in my mind, wind power. It's like, okay, we've been doing this, we've got it fairly dialed. We have the grid connections and, we've kind of figured that out. So it seems like with marine energy that there's still just a ton of, understanding and figuring to get those connections, if that makes sense.
That does make sense, and I think that's part of the excitement of the field. And I think that what I'm hearing about these answers is that some of these are transferable skills. Like you learn how to work in marine energy. It also applies to other energy sectors. Like from my perspective, I think coming at marine energy not from the energy background, but more the coastal science sort of the ocean side of the equation, I see marine energy as one part of a whole set of things we're doing in the oceans. I'm able to work on aquaculture and other sort of aspects of coastal and ocean management too. So I think it's important, I think, when you go into a field, knowing that you don't necessarily have to just be a deep diver. You can dive deep and you can also spread out a little bit and take on new skills and interests. Any other thoughts on that one before I move on to the next question?
Yeah, I'll just add, oh, sorry. Would you like to go ahead? Okay.
Hannah and then Kayleen. Go ahead, Hannah.
Yeah, just I put this a little bit in my answer in the Q&A box, but I think uh it is kind of hard to compare marine energy to other well-established energy sources. And I think being at NLR has been and working in water power has been really interesting because there's a really big wind research group here, and some of the folks in wind who I work with have been doing this since for the last 30 to 40 years, and were around when wind was kind of at the stage that water power is now. And so sometimes we hear seminars or kind of conversations about what wind research looked like in the 90s. And there were all sorts of like gearbox issues, reliability problems, that sort of thing. And that is not really talked about much anymore because those are problems that were overcome by the industry. And so it kind of feels like that's where we're at now with water power. And there's a lot more work to do. But there's definitely like research and work that can be done to try and answer some of those questions.
Great points. Go ahead, Kayleen.
Yeah, I was going to speak a little bit to your point, Simon, that you don't necessarily have to be focused on marine energy to work in that space. And a lot of the team members I work with on Triton came from other energy sectors and just applied their knowledge to marine energy and the environmental effects space, because we can learn a lot from analogs from other ocean activities or energy activities where steel is going in the water, related to environmental effects and interactions. So having folks who have worked in the wind space or other ocean activity spaces and have understanding of acoustics or animal interactions, bringing that to marine energy has been very useful, because a lot of the same principles apply, and you just want data around, specific devices. But when you don't have marine energy devices in the water all the time to monitor, you have to borrow from those other industries. So there's a lot of value there.
There it is. Excellent. Jeff, the next question I have is for you. So I was going to direct it to you unless you have a thought on this question too.
Yeah, I can give a quick thought
Yeah.
before we move on. Definitely echoing what other people have said. I think within the kind of renewable energy space, wave can really help kind of balance solar and wind, especially with solar. It often kind of correlates to the strong wave energy times are the weak solar times. And so can really help when used in combination with other renewable energy sources. So even though, yeah, obviously we're not at a great point to assess reliability in the future, and there's certainly a lot of concerns that make for interesting research problems. There's a lot of potential, which makes it exciting.
Great. Thank you. And the question I was going to ask, which Linnea answered in the chat, but maybe it's worth a little bit more discussion. There's sort of a general question that I have around key skills for a career in marine energy. And Javier asked, do you consider learning coding languages and databases important for entering the marine energy field? And I was curious about your thoughts on this, particularly Linnea, Jeff, and others who are kind of working with a lot of coding languages, about what you're seeing in the world of AI and how that's changing maybe some of the skill sets and ways you might be thinking about the need to learn certain skills. So long question there, but what's your thoughts on learning some of these sort of traditional coding skills, database, et cetera, and how is AI maybe changing that? Starting with
Yeah,
Jeff.
yeah, I can go first. I think certainly coding skills are very valuable, and having that kind of problem solving mindset and just understanding of how programming languages work is certainly very valuable. Still, I think even with the um, AI coming on and everything, I still think that understanding. Um, I think with AI, the a skill that will still be really valuable is being able to kind of formulate problems in an effective way that um, AI can certainly help get all the code written and formatting and everything. But if you don't really understand the problem yourself, it's hard to make it do what you want it to do. It can't come up with answers on its own, so it really needs those kind of good prompting and a good background on your end. So I think having that good understanding of how programming languages work, as well as formulating problems, is two things I would say.
Great. That's really helpful. Any other thoughts on some of those? We can talk about coding, AI, or other just essential skills that you think that folks need to have to maybe have a leg up in this field. And if not, we can also move on.
Being comfortable with asking questions and not always getting answers and asking more questions. Being comfortable with uncertainty and just getting really curious feels like an essential in a field like this.
Yeah, that's a core life skill for sure. That I think that one never goes out of date. I was going to ask a question that maybe kind of gets into this as sort of a lead into skills. I think the skills you need are kind of based on the problems we're facing. And there were a couple of questions in the chat that I saw got answered around, some of the key challenges facing marine energy as far as like moving it forward as a commercial technology. And, I saw permitting mentioned as a challenge. There's some key technical challenges, but maybe just, I know we only have about 8 minutes until we're going to close out, but are there just key challenges that you see that are like, maybe I'm going to ask you to be optimistic, like an exciting challenge, something you think that we could maybe overcome in the next 5 years? Maybe another way to think about this is if you were just finishing or just starting your graduate program, what problem would you want to focus on? I see wheels turning. I'm looking for eye contact. How about Sarah?
Um, sure. So, yeah, so just skills and problems. I would say maybe just thinking about scaling. It's like from the projects that I've been involved with, they've been pretty small scale. I mean, like we can't compare, apples and oranges, but we've got multi-megawatt turbines, multi-megawatt battery storage, multi-megawatt solar. So I guess for me, a question that I would be asking is like, okay, how can we take this little bespoke, wave device or, you know, and I'm sorry if I don't mean to offend anybody. It's like just the things that I've been working on have been like these kind of, smaller little projects. So I guess in my mind, it's like, okay, how can we take that and scale it to actually provide, a really usable amount of power? You know, just to get it to that point where it's this real thing that's, it's connected and, it's powering cities and, you know, desalinization and, things that we really need. So I guess my question would be scalability of the devices.
A huge one, scalability, going from ones to twos to tens to hundreds, and really able to capture a significant amount of power to kind of take its place in that pantheon of other energy generating technologies. So thanks for that, Sarah. Anybody else? Any other sort of big optimistic challenges that you're excited about? Or maybe you're freaked out by? How about Linnea?
Yeah, just thinking about one area of research that I've been thinking and talking about a lot recently is efficiency for some of these devices, because they have to deal with these like big changes in power levels. For turbines specifically, you have a pretty low average power, but then you have really high peaks when you have your peak tidal velocities. And I think I see a lot of mechanical research around turbine form factor and what's going to make blades most efficient. But what I think I see missing from the space a lot is that electrical efficiency. How do we harvest energy efficiently at a range of different voltages? And there are definitely people doing this. You see Embari working on specific power electronics for their WECs. But I think this is still a major area that can have a lot of work done in it in the next 5 years.
Scaling and efficiency. Love it. Anybody else?
I can
Yeah.
go next. Definitely thinking kind of in my own field of wave energy numerical modeling. But I think we have at least decent understanding of how to design performing wave energy converters in terms of like power output. But I think understanding these reliability concerns and kind of survival concerns is will be huge going into the future. That's kind of a lot of where a lot of wave energy converters fail is kind of surviving in real ocean conditions. So being able to consider those questions early in the design stage, I think could be really important going forward. And it's definitely something I want to explore more.
Other side of the efficiency coin, what is how can you make it last a long time in the ocean as well, which is a very challenging place to work. Hannah or Kayleen, any thoughts on interesting problems and things that you would like to work on? How about you both came off mute at the same time? I see Hannah.
Yeah, I was just gonna kind of follow on from what Sarah said about like the scaling question. I think kind of hand in hand with that is this challenge slash opportunity of identifying, the specific places where marine energy really does work well and really does make sense, kind of independent of the scale that it's at. And there are definitely cases where it's the cheapest energy option, and the energy option that makes the most sense. And so I think identifying those opportunities and really trying to push to kind of show that marine energy can be the energy production method that makes sense in certain cases, is kind of an important and maybe achievable nearer term goal.
Kayleen?
Yeah, I'll come from my lens as somebody who works a lot in like the social science space and with environmental effects. Something I think a lot about is that marine energy is an unknown and sort of mysterious energy resource for a lot of communities still. And there are challenges associated with that because you've permitted a device, but if the community has a lot of pushback or a lot of concerns, that's really going to rise to the surface and it's going to contribute to a lot of misinformation and a lot of challenges there. So understanding how we can hear the concerns of communities, can we address those concerns? Are they tied with environmental effects questions? All of those types of questions, I think, will really help move the marine energy industry forward when devices start getting permitted. Oh, I'm struggling with that today. Permitted and in the water. So that's something that I'm really interested in because it feels like you can do a lot of community work and research in that space that can help with like co-development and things like that to like make the industry more successful moving forward. And I'm excited about that space.
Lots of great things to work on, and it's an exciting field that as we make progress, there's always new questions coming up and the need for new skills. And it's really exciting to see the growth in this field over the last 15, 20 years, and the number of people on this call is a testament to that. So I think we're basically at the point now where I need to thank the panel and turn it back to Michaela to close us out. I'll just note there are a couple questions that are still open in the Q&A, and one was there was a whole set of questions really, I think, around sort of international collaboration. There's a specific one now related to core power and some testing there. I don't know if anybody who's worked with core power might want to take that question offline and answer it in the chat. And then, I think Michaela, you might get to some of these other questions I saw about kind of the specifics of how one starts their career at a national lab, and are labs still hiring, at this time, and, the level of, the ability to kind of get your foot in the door. So I will probably just hand it over to you to close us out. And I'll thank our panelists for a great panel and for all of you who participated with great questions. So thank you very much.
Thank you so much, Simon. That was wonderful to have you moderating. And thank you so much to all of our panelists. We've all been busy answering questions in the Q&A box. So please look through those for questions both that you've put in there and that others on this call have as well. We will try and keep answering those through the end of this event. So if you have more questions, please continue to put those in there. For the next few slides, I'm going to go over some opportunities that we have at the labs. And similar to Simon, I also need to find exactly where my notes have disappeared to. So first, and I think this will answer some of the questions that we have in the Q&A box. So first is a Marine Energy Fellowship, also called an ORISE Fellowship. This is a program that's open to current and recent graduates in both STEM and non-STEM disciplines. It's a really great opportunity for hands-on experience in marine energy research. And there is a host of different folks that you can work with depending on who's kind of signed up to host an ORISE fellow. So this is a 12-month fellowship. It's fully funded. There are various host facilities, so you can go on the website and see who is open to hosting. We, OES Environmental at PNNL, are bringing in our first ORISE fellow starting actually next month that we're really excited for. So a great avenue to work with a national lab, or there's federal agencies and other organizations that host a marine energy fellow. We think the next application period will likely be in September, so keep an eye out for that. Next up is summer undergraduate laboratory internships, or SULIs. I think I heard someone talk about that during the panel. This is a really great program to get experience working at the DOE lab specifically. It's open to undergraduate and recent graduates, and it can be really, really wonderful entry points into the labs. Many staff get their start there as SULI interns. So it's a great way to see how the labs work, get experience, start to network. There have been people who have been a SULI intern at one lab and then had a career at a different lab. So it's possible to kind of try out and see how the different labs work and what they work on. Also at the bottom here, we have a quick note about a visiting faculty program as well, which we've linked here. There are other grad student opportunities, like the Science Graduate Student Research Program, which helps advance your PhD research while working at one of the labs. And then on the right here, we've linked to opportunities at each of the 3 labs that have been highlighted today. So these are for postdoctoral fellowship programs. For all of these links here, I think Jacob is putting some of the links in the chat, and then we also will have these slides available on Tethys after, so you can access any of the slides and find their links easily there. Anyone who's registered will get a link when we have that available. I know this is a lot of information, so again, this will be recorded and put up, but we did just want to provide all the possible opportunities here. So the MECC, Marine Energy Collegiate Competition, which I think I also heard talked about as well, is an annual competition. It's managed by NLR and it's funded by Department of Energy. It's engaged hundreds of undergraduate and graduate students from across the country, and there's also been some international engagement as well. Ariel, who is one of our organizers of this event, is online and she helps run this, so can answer some questions. There are 2 leagues. There's the kilowatt and megawatt, which I think these are new as of last year. So kilowatt really allows kind of introductory participation, whereas megawatt is for more that advanced full engagement. This is a really wonderful way to get lots of hands-on experience in marine energy. You get lots of wonderful industry contacts. It's really great for skills building and building out your resumes. And it doesn't hurt that there's also a cash prize. And applications for this year's competition are due very soon on May 1st. So if you haven't checked it out already, please do so quick. We know that's coming up. So hopefully some of you on the phone are already looking forward to this as an opportunity. So I think the last or second to last here are young professional organizations. There are many of these different groups, and this is also a great way to join if you're interested in a career in marine energy. They allow you to connect with peers, find mentors, stay up to date on events and industry developments, and really help expand your network. Some of these groups like INOR have annual meetups. I think INOR has 2 this year that I've heard of, one in the US and one internationally. I've attended one of their events as a National Lab staff, sharing my experience there, and they're really wonderful gatherings with young professionals. So I highly recommend looking up some of these professional organizations. And then last, if we didn't already share enough links with you, we have more. There's lots of online resources from the different labs here, and both online resources you can take a look at, as well as newsletters like the Tethys and Primer Blast, which are biweekly newsletters where you can stay up to date on job opportunities, conferences, industry news, and more. And again, you'll have these slides after the event, so you can easily find the links. And we just want to say thank you so much for joining. We really appreciate you being here. Y'all asked some really wonderful questions, and I'm glad that the panelists were able to respond to those both in the Q&A box and through our discussion. And thank you so much to Simon for moderating and imparting your wisdom as well. So thank you again for taking the time to do this. The very last ask I have of everyone who has attended today is we would really love your feedback for this event. It really helps us make sure that this event is useful for those of you looking at marine energy careers. Also understand what you'd like to see from us for future events. So this is a really short 2 or 3 minute survey. It would be really wonderful to have you take it and provide us some feedback. So with that, I think that is my last slide. So I'll stay on there, but thank you so much. We have a few minutes, so I will just quickly check out the Q&A box. Let me see if I can do this while presenting. I don't see any unanswered questions, which is wonderful. So I think we're all set there. With that, I think everyone loves to get back a few some time when we're on calls and everything. So I'll just say thank you so much for being here. Thank you to our panelists. Thank you to Simon. And I hope you all have a wonderful rest of your day. You'll all get an email with the link when the recording and the slides are available online. So thank you, everyone. Really appreciate it.